Okay, let's work some examples. In this example 1, it says write a fraction to represent the shaded part of the figure. Okay, so the first thing we want to do is we want to say, okay, in my fraction, I've got a numerator and a denominator. Remember, the denominator talks about how many pieces make up a whole. So if I were looking at this figure, there's 1, 2, 3, 4, 5, 6, 7, 8 pieces that make up that whole entire figure. Now, the numerator talks about how many pieces you have. So here we have 1, 2, 3 that are shaded. So we're talking about having 3 out of 8 pieces that are shaded. So that's the way we would look at that. All right, for example, 2 and 3, those are very similar, so I want to do those together. It says write 3 fractions equal to the fraction 10 over 11. So we have 10 over 11 equals something over 77. In this case, what we're doing is we're creating equivalent fractions. So what we have to do here is we have to look at this and say, what do I multiply 11 by in order to get 77? Well, that would be 7, correct? Well, there is a rule in fractions that says you can multiply anything you want to a fraction as long as you do the same thing to the numerator as you do to the denominator. That way, you're technically only multiplying by 1. So if we have to multiply the denominator by 7 in order to get 77, we would have to multiply the numerator by 7 also to get 70. So our answer would be 70 over 77. Now then for the next one, it says 10 over 11 is equal to what over 44? So again, we need to ask ourselves, what are we multiplying by to get 44? Well, that would have to be a 4. So we have to do the same thing on the top so that we're only multiplying by 1. And 4 times 10 would give us 40. So 40 over 44 would be the same thing as 10 over 11. And then finally here, same concept, we want to change 10 over 11 into something over 33. So what do I have to multiply 11 by in order to get 33? That would be a 3. So I'm going to do the same thing to the top so that I'm just multiplying by 1. And 3 times 10 would give me 30. So 30 over 33 would be the same thing as 10 over 11. Now, we can also do that even with letters and things. So, and if we were going to go on and do, more of this chapter, which we're not, then we would be working more with letters. But we're just going to stop here so that we have plenty of time to be able to study for our last test. So this example again says write 3 fractions equal to the fraction a over 6. So again, I need to change a over 6 into something over 12. So what do I have to multiply 6 by to get 12? And that would be a 2. So I'm going to do the same thing to the top so that I'm just multiplying by 1. And 2 times a would be 2a. So 2a over 12 is the same thing as a over 6. All right, in the next one, what do we have to multiply 6 by in order to get 84? And for this one, you might need your calculator. So what do we need to multiply 6 by? That would be a 14. So I'm going to multiply the same thing on top so that we're just multiplying by 1. And if you'll remember, 1 is the multiplicative identity. It's what you multiply to something and it doesn't change it. So 14 times a would be 14a. So there would be our final answer. And now finally, we're going to turn a over 6 into something over 72. So what do I have to multiply 6 by in order to get 72? And that would be a 12. So I'm going to do the same thing to the top so that I'm only multiplying by 1 technically. And 12 times a would be 12a. So that would be my final answer. All right, and then finally we have example 4 here that says write the fraction in lowest terms. Well, as we've seen in these last two examples, we can write fractions with different denominators that mean the exact same thing. We multiplied to get a what appeared to be, I guess you could say, a larger fraction, even though it's the exact same, but it had bigger numbers anyway. So if I were going to go backwards, I would have to do the opposite of that. Instead of multiplying, we're going to have to divide. So this one that says write the fraction in lowest terms, we've got 18 over 48. So we needed to see what can we divide out of both of these terms. So I know that the top number can be divided by 2, so I'm going to do the same thing to both the top and the bottom. So 18 divided by 2 would be 9, and 48 divided by 2 would be 24. Now, we always have to ask ourselves, is there something else that we can divide out? And in this case, there absolutely is, because 9 is divisible by 3, and so is 24. So 9 divided by 3 would be 3, and 24 divided by 3 would be 8. So our final answer in most simplest form is 3 over 8. Now I do want to take just a minute to show you why that is happening, why you're able to do that division. And in order to do that, let's look at the prime factorization of these things. So let's look at 18. 18 is 2 times 9, and 9 is 2 times, I'm sorry, no, not sorry. I did it incorrectly, and I cannot get my eraser to work. There we go. 9 would be 3 times 3. Trying to do this on the fly, and it's not working out so well. So I could rewrite that numerator as 2 times 3 times 3. Okay, what about the 48? Well, let's see, 48 I know is 4 times 12, and 4 would be 2 times 2, and 12 would be 2 times 6, and 6 would be 2 times 3. So I could rewrite 48 as 2 times 2 times 2 times 2 times 3 if I wrote them out in their prime factors. Now by doing that, remember when you have the same number over itself, that's technically just a big old 1. So 2 over 2 is technically a 1. That's why we can divide it out or cancel it, because it's really a 1. And 3 over 3 is really a big 1. So what we're left with here on top is just 3, and on bottom we're left with 2 times 2, which is 4, times 2, which is 8. So you can look at it either way, but this is what's really going on, and now we can take the shortcut and we can divide and make it a little bit easier.